Alright, so I'm going to do a simple surveying calculation where I have two known coordinates, and I'm going to use those two coordinates to reestablish the locations of two missing or unknown iron posts. So in this simulation, I have point number 1 over here and point number 5 over here. Those are going to be my measured iron posts, which are essentially known, or I'm going to assume them as known. And I'm going to use those coordinates to reestablish the blue circle here, which is going to be point number 2, and the red circle here, which is point number 4. So first things first, I'm going to jump into Trimble Access, go over to my project. I already have a sample project made up for this. I'm going to open that as well as a sample job. Here are my properties. I'm working in UTM in Zone 11 North, and I'm using the 2002 model of the Canadian geoid model, I guess. So right off the bat here I have points number 1 and number 5 keyed in because they're essentially known. I have northing and eastings for them, so I can just key them in and start using them right away. So my first step is going to be to or I guess find a theoretical location for this blue circle here, or point number 2. So just looking at the plan, I see 950.94 right off the hop. And I know this plan is from the early 1980s, and that in Canada, most plans were switched over from imperial to metric in the mid 70s. So right off the bat, I can assume this is 950.94 meters rather than feet. But then just to confirm that, looking around, these numbers just seem weird to be imperial. They seem too small to be imperial, so that confirms what I believe this to be in meters. Of course, I can always look at the scale bar on the plan or whatever, but I'm not going to pan over there for this simulation at all. I'm going to assume this is all I have to go off of. So I have the 950.94 meters, but I don't have a bearing from point 1 to point 2. So what I can do is take an assumed bearing. Because the bearing is going to be arbitrary, like I'm going to work my way through and I'm going to get a calc point for point number 5. It's going to land down here or up here somewhere. And then I'm going to have to go through and find the azimuth between my known points and then my starting point and my calc point, and then find a correction and then redo all my calcs and then see what my error is. My second calc point should land really close to 0.5, and then I'll have my established coordinates for the blue circle here and the red circle, or points 2 and 4. So because the bearing is pretty arbitrary, I can just assume a bearing. So just from looking at this, I'm going to assume north is straight up and down the page. This isn't part of the plan. I created that just to show my thought process. But I'm going to assume a bearing of 300 degrees. Again, just because I'm assuming north is straight up and down here. So I'm going to go back to Trimble Access. I'm going to go to Kogo, compute point. This one's going to be point number 2. It's a calc point. And I'm going to use the bearing and distance method. So my start point is point 1 measured. And my assumed azimuth is going to be 300 degrees. I don't need a delta azimuth right now because I haven't found my corrections yet. When I go through a second time, I'll apply my correction right here rather than doing the mental math in my head. So the horizontal distance, 950.94 meters. Store as grid. Done. So the next point is point number 3. And going back to the plan here, point number 3 is going to be the yellow circle, by the way. I know that point number 3 is the intersection point between these two baselines. The baseline connecting points 4 and 5, and the baseline connecting points 1 and 2, or 2 and 1 here. So I have a distance of 25.90 from point 2, and I know that this is just an extension of the baseline. So I can either assume that this is just 180 degrees. I can use turned angle and distance to figure out this point with a 180 degree turned angle, or I can just do from a baseline in Trimble Access. So I'm going to do, so point 3, calc my method is going to be turned angle and distance. I will do baseline for the rest of the calcs, but just to show this one, I'm going to do that. My start point is going to be at point 2. My end point is going to be point 1. My turned angle is going to be 180 degrees, and my distance 25.90 from the plan. Store as grid again. So my next point is point 4, and this one's going to be a little different because we're changing directions here. I can't keep continuing to use this baseline, and I don't have any information further down towards point 5. However, what I do have is the exterior angle of, I guess, what you would call the intersection of these two baselines. And so what I'm going to do is take a turned angle and a distance from my calced point 3, starting at point 2 and going all the way down to 4. So the way I can do that is find the interior angle of this intersection, which is going to be 360 degrees minus this angle here, 249, 1955. So going back to Trimble Access again, point 4, calc point. I'm going to use turned angle and distance again. Start point is going to be 3, end point is going to be 2. My turned angle, this time I'm going to go into the calculator, is going to be, let's get rid of that, 360 degrees. And then the calculator is in reverse Polish notation, so press enter. 249, 1955, and subtract the 2, and there's my interior angle. Except this distance is 25.97. I'll just double check that. Yep, 25.97. And I can calc it out. My next point is going to be point 5, which is the final point that I'll be able to compare to my measured point. And this one I'm just going to use from a baseline, just because it's simple. I know that the point 5 is just an extension of the baseline connecting points 3 and 4 here. And the distance is 745.14 meters. So my method is going to be from a baseline, 3 to 4, 745.14 meters, and it's going to be out from the end. Store. So the next thing I have to do is compare my azimuth between my start point and my calc point, and my start point and my actual point. So I can go to Kogo, compute inverse. I'm going to do my actual first, so I'm going to go from point 1 measured to point 5 measured. So I have my azimuth to be 321 degrees, 13 minutes and 52 seconds, and my horizontal distance to be 1,441.828 meters. So I actually have this already written down, so from my start point, my measured start point, to my end measured point, I got that exactly as it is here, 1441.828. Then I can do the same thing for my calced point, which is 0.5. So same thing, I'm going to take note of that azimuth and distance and write it down here. I don't know why there's a W there, but alright. So next I need to figure out my corrections. I know that my correction is going to be, for the azimuth anyway, the azimuth I need to add to my calc point to get it to be the measured point. So simply I just subtract my measured or my calced azimuth from the azimuth connecting my two actual points, and that gives me 51 degrees 14 minutes 37 seconds. For my scale factor correction, I'm going to similarly just take the distance from the actual the two actual points and divide that by the distance between the actual and the calced point, and that gives me a scale factor of just under 1 here. So next I'm going to basically redo all my calcs, but with incorporating the corrections into my calcs. So I'll go into Kogo, compute point. This one's going to be 2 corrected, calc, bearing and distance, like I did last time, the exact same way I started out. So I'm going to start at point 1 measured, and my azimuth is going to be 300 degrees, same as what I used before, and as you can see the guideline already shows up and it's going right through 2 and 3 there. But this time my delta azimuth is going to be equal to my correction, so 51.14.37, 51.14.37. And I don't know why, but it's changing it to 22, so I gotta go into my calculator and just retype it. 51.14.37. Perfect. So that's good to go. My horizontal distance is going to be this distance, 950.94 multiplied by my scale factor correction. So if I go into my calculator here, I'm going to type in my scale factor just quick. And actually, I might already have it here. 999,595,122,61407. Yeah, perfect. So I have my scale factor correction here. I go enter, put in 950.94. I believe that was it. 950.94, yeah. So I'm going to multiply those two, accept, and it's populated there for me. So calc that point, 3 corrected. So this one I'm just going to do from a baseline just because it's easier. So start point is 0.1, end point is 0.2, or 2 corrected there. And my distance is, I'm going to have to go into the calculator again, recall memory, and I know the distance is 25.90. Multiply the 2 and accept, out from the end. Perfect. Next point is 0.4, and correct it again. So this one's going to be turned angle and distance because I'm going this way now. Changing directions, so my start point is going to be at 3 corrected. Oops, corrected. End point is 2 corrected. My turned angle is going to be 360 degrees. Enter. 249, 19, 55, and subtracted, and there it is again. Same angle as before, that doesn't get scaled at all. My distance is going to be, recall my memory, and I know the distance to be 25.97. So I'll multiply those two, and there's our distance. So there's 0.4, 0.5, we're going to call it 0.5 corrected. I'm just going to do from a baseline again, just because I think it's easier. 3 to 4. And the distance is, for that leg, 745.14 there. 745.14. Multiply the 2 and accept. Perfect. So now I can get out of here, pan out a little bit. And so, as you can see, I have 1, 2, 3, 4, 5. This is what the original ones were. And then my corrected ones went all the way up north, I guess, and then back across. And as you can see, the 2 corrected and the measured are actually really close. So I'm just going to go to pan to point, 5 corrected, at a scale of 0.1 meters. Okay, so yeah, even at a scale of 0.02 meters, they're super close together. So highlight those two, compute the inverse, and boom. So my horizontal distance on the ground is 0.006 meters, or 6 mils, and then 3 mils in the north and 5 mils in the east. So that's pretty good enough for me anyway. And from there, like, I would go to, I guess if I was doing this in the field, I would go to pan to point, and I would go 2 corrected, at the same scale or whatever, and I would have a location for this. So I can, highlight it or whatever and stake to it, or like review it, and I have my northing and easting, and that's the coordinate I would use for my blue circle here, or my missing post. And I'd do the same thing for this one. Alrighty. So yeah, that's reestablishing the coordinates of two pins when you have the locations of two other pieces of evidence on either side.